afternoon, guys. Hello, how are you? I hope that you are good. For today's lesson, it is about the chemical changes and chemical reactions. So maybe I will explain both of them together. So as you remember that when we explained about the physical changes, I said when I have this paper, I just cut down the paper. It will change the shape, the size, and the number of the pieces. Like from one paper, maybe it will become two pieces of the papers, right? So I say that I just can change the shape, size, number of the pieces. But about chemical change, it is really different with the physical changes, guys. So I had that egg, I boiled the egg, yeah, and I have this egg now. So from the chemical change, you can say to me now it's like a chemical change because I produced new substances, which is really different from this one, right? So I cannot return this one back to become this one, right? So the difference is because I've got new substances, like which one, the first one is white and then the yellow one, and from here, which is really totally is different from this one. So when I produce a new substances, I cannot return back to the original one. Can you tell me, like, if I can return back this one to the original one? No, I cannot do that, right? Okay. And also another example is let's say that I burned this paper. Okay, so I have ash now. I've got the ash. Can I return back the ash to the original paper? I cannot do that. So anything that I cannot return back to the original one, I can call it as a chemical changes. So the chemical change, it means that the new substances will be formed. As you can see from the original one, I've got a new egg, which is a chemical change. Even when I'm burning the paper, it will produce the ash, which is a chemical change. Yeah. Okay, let's continue with the reading of the book, and let's continue with the explanation. I'm gonna move these things away, and then I will bring my book to chemical change and properties. So guys, as you say that chemical changes, they are different from the physicals. It is page 234. It's about chemical changes and its property. Okay. An egg that's cracked open has gone through an irreversible physical change. You cannot put the egg back into the shell. So guys, I've got the shell. So these are the shells of the egg. So can I put the egg inside of the shell? I cannot do that, right? So if I cannot do that, I know that if I put this one inside of this one, I cannot close it, right? So it is a physical change, but because I say it's a physical change, because we don't have new substances, because new substances will not be formed, right? Okay. You cannot put the egg back into the shell. If the egg is cooked in a scald, the egg white and yolk change from a liquid to solid. As you can see that from the liquid it became a solid. So what I did, I changed it. I changed the let's say that I changed the form, and I changed the shape. From the liquid it became a solid, right? Maybe you're gonna say to me, Miss, what about H2O? When I am changing H2O from liquid to solid, I said to you it is a physical change. Why? Because we still have the particles of H2O, which is from liquid and then to the solid. All of them, they are the particles of H2O, right? Because I can return back the solid to become a liquid, or liquid to become a solid. If I can do so, I can say this is a physical property. Where is it? I can call it as it's a physical property, right? But if I cannot do, I say it's a chemical change. Okay. But this kind of change is different. The egg white has changed color. As you can see, it's changed really. It's with this one, right? It's changed. Okay. This is one of the signs that the egg has gone through a chemical change. So now we have the definition of a chemical change. Here we have it. New substances have been formed. So this one, new substances have been formed. I don't have the highlighter today, so I'm just using the red one, red pen. You can use your highlighter. Here's the definition of the let's say that here's the definition of chemical change. New substances have been formed. Okay, and although the same atoms are still present, same atoms are still present, they have been rearranged in a different structure. So we say that if the atoms in the egg, if any atom is inside of the egg, in this let's say that in this egg, which is the new one, we have the same atom but in a different, they arrange it in a different way. Yeah. Okay. Now, most chemical changes either require energy or release energy. Require energy. So most chemical changes now, I cook it, not cook it, I, let's say that I cook it, yes, if I put this egg in the fire, right, after a while when I produce this one, it means that I really needed some of the heat, that the egg will be changed from this form to this form. So I needed heat, I needed energy, right? So the heat, I can call it, which is energy, it will take the energy, it will take the heat to become in this form, right? Okay. Most chemical changes either require energy to release energy when an egg becomes a solid, right? The energy, the change uses energy in the form of heat. When coal burns, forming carbon dioxide, the chemical change release energy in two forms: heat and light. Okay, when we have a fire, right? So it will produce two things. The fire. The first thing is heat, because it will give you heat. The second one, it will produce light, right? Okay, so even just like this, as you can see, this fire, it will produce heat and light, right? Also this one, yeah. So what do we say? The chemical changes, they required energy, they will release energy. So we have another definition, which is we have a new form of endothermic reaction and exothermic reaction. We're going to see what is the differences between them and what is the meaning of them. A chemical reaction that absorbs energy from the surrounding is the endothermic reaction. So guys, now what do you call this one? Is it exothermic or endothermic? You're gonna say to me it is endothermic because it will take the heat. So if any substances that you will see it will take the heat, we can say it is endothermic reaction. Okay, why? Because it will take the heat, it will take the heat. So always remember that endothermic reaction, it means it will take the heat to itself. It will absorb the heat. Absorb heat is better. Absorb the heat. It will absorb the heat. So this is what we call as endothermic reaction. What about the exothermic? A chemical reaction that release energy is an exothermic reaction. So releasing of energy, it's what? It's exothermic. We say absorbing of the heat is endothermic. So releasing energy, releasing heat, yeah, releasing energy or releasing heat, it's what do we call as a exothermic reaction. So what was this stage when we are boiling the egg to become this shape? We said this is endothermic reaction. Why? Because it will take the heat to have this shape. If I give you another example of exothermic and endothermic, I take it out from my laptop, is endothermic and exothermic. So this one, the first one, this one is endothermic reaction. Why? Because this ice, it will take the heat from surrounding and it will melt, right? It will melt. So when it will take the heat from the surrounding, so we can call it as endothermic. Exothermic is we have a fire. The fire, it will give to its surrounding. When it will give the heat to its surrounding, we can call it as exothermic. Yeah. Okay. I will come back to you with the other definitions. I just hope that you will make the differences between endothermic and exothermic.